My dear students, today we will solve the remaining two properties of rational numbers. First five properties we have learned and two properties remaining. That is, sixth property is that property of zero. This property means that when we multiply any rational number by zero, the result will be zero. Example, negative 3 upon 5 into 0. 0 means it is 0 upon 1. So if we multiply, we get negative 3 upon 5 into 0 upon 1. Here when we multiply 3 into 0, 0 and 5 into 1, 5. Then 0 upon 5 means it is 0 only. So any rational number, if we multiply with 0, then the result will be 0. So this property is called a property of zero. The next last property, distributive property of multiplication over addition and over subtraction also there. Here multiplication is distributed over addition. Here you can see that P into Q, P upon Q into R upon S plus T upon U. Addition and the multiplication is distributed over addition here is equal to P upon Q into R upon S. Means with this first number we multiply this number and then plus, because here addition, and P into Q, P upon Q into T upon U. Here first number is multiplied by third number and in between plus. So this is called distributive property of multiplication over addition. And here when we solve this both sides, we can see that both sides are equal. That we can check by giving different values to these variables. P upon Q, that is we have given negative 5 upon 8, and R upon S, its value is 3 upon 5, and T upon U is 2 upon 5. Then according to distributive property, negative 5 upon 8 into negative 3 upon 5 plus 2 upon 5 will be equal to negative 5 upon 8 into 3 upon 5 plus negative 5 upon 8 into 2 upon 5. Here we solve both sides and prove that these are equal. First we solve this side. Here inside the bracket it is should be solved first. This addition and denominator is same, therefore we add it. Negative 5 upon 8 into 3 plus 2. One is negative, another is positive. Therefore, it will be negative 1 upon 5. Then, next, here 5 multiplication. This 5 and 5 we can cancel. We can cut it. Then we get negative 5 upon 8 into negative 1 upon 5. Here both 5 can be cut. Then here negative 1. And the next negative 1 into negative 1 is equal to positive 1. And here 8. 1 upon 8 is the answer. Let us see the next side here. Here also multiplication, then after addition. 5 and 5 we can cut. 1 and 1. Then 1 into 3. Negative 3 upon 8 plus this plus. Then here also negative 5 and 5 we can cut, and 2 upon 8 we can cut. 1 upon 4. Then the remaining answer will be negative. Here both negative, that changes to positive. Here negative 1 upon 4. Then next we want to add, that is addition. Addition denominator should be same, but here denominators are different. Therefore we have to find out the LCM of 8 and 4 and make it equal. Then negative 1 upon 4. 4 should be multiplied by 2 to get 8. Therefore we get 3 upon 8 plus negative 2 upon 8. Then denominator is now equal, therefore we add it. negative 2 and 3. If we add, we get 1 upon 8. So here also we can see that both sides are equal. So this is called the distributive property of addition, of multiplication over addition, and over subtraction also there. In this way we solve that. So we have now finished all the properties of rational numbers regarding multiplication. Now we move to the exercise, remaining questions of the exercise. Now students, we are going to solve a fourth question of exercise 1.4. First, second and third question we have solved previously in our previous class. Now we are going to solve fourth question. Fourth question is, multiply negative 9 upon 16 by the multiplicative inverse of 15 upon 16. That's the question. That means this number we have to multiply by the multiplicative inverse or reciprocal of this number. So here first we rewrite it. That is equal to negative 9 upon 16. This number we multiply by the multiplicative inverse of 15 upon 36. What is the multiplicative inverse of 15 upon 36? It is 36 upon 15. Then if it is possible, we can cut and reduce any numbers. Here you can see that this negative 9 upon 16 and 36 upon 15. These numbers can be cut, can be divided or made into small by cutting with the common factors. Here 16 and 36 we can cut by 4 or 2, and here by 3 we can cut. So he cut by 3, 3 3s are 9 and 3 5s are 15. Here we can cut by 9, 4 or 2. Here by 4 we cut, 4 4s are 16 and 4 9s are 36. If it is possible to cut and reduce, again we can cut and reduce, but here there is no common factors. Therefore we rewrite these numbers, negative 3 upon 4 into 9 upon 5. Then we multiply 3 into 9 upon 4 into 5. That's equal to 3 9s are 27, negative 27 upon 4 5s are 20. We can change this into mixed fraction if it is needed, but not necessary. We can stop from here. Now question number 5. Simplify and verify the distributive property of multiplication over addition. Here we have to simplify, and then after we have to verify also. So first we will do simplification of first question A. Second question B is a homework for you. Negative 13 upon 17 into negative 3 upon 4 plus 1 upon 2. This first we simplify. You know that is for simplification we solve first inside what is given inside the bracket, that is negative 3 upon 4 and plus 1 upon 2. That we want to add first inside the bracket. Negative 3 upon 4 plus 1 upon 2. And for addition, you know that we have to make the denominator equal. So by LCM, here LCM is 4. So we multiply by 2. Then we get 13 upon 17 into negative 3 plus 2 upon 4. That's equal to 13 upon 17 into 1 upon 4. For multiplication, we multiply numerators together. 13 into 1 is equal to 13 and 17 into 4 is equal to 68. So answer will be 13 upon 68. So simplification is over. Now verification also asked. So we want to verify the distributive property of multiplication over addition. So we write here distributive property, first we write verification. What is distributive property? Distributive property says that P upon Q into R upon S plus T upon U is equal to P upon Q into R upon S plus P upon Q into T upon U. This is distributive property. So here we are giving different values to variables. So first we write P, we take 13 upon 5, first number, 13 upon 17 into R upon S means negative 3 upon 4 plus 1 upon 2, that will be equal to 13 upon 17 into negative 3 upon 4 plus 13 upon 17 into 1 upon 2. So first we verification, both sides we want to solve and we want to prove that both sides are equal, that is verification. So first this side we solve. Already we have solved that, we write here 13 upon 17 into negative 3 upon 4 plus 1 upon 2 into 2. That's equal to 13 upon 17 into negative 3 upon 2 plus 4. That's equal to 13 upon 17 into negative 1 upon 4. Okay, here it is negative, previous question. So here also negative will come. Then it will be equal to negative 13 upon 68. So one side we solve. Next side we have to solve. Next side is LHS. That's equal to, here we draw a line. Here multiplication, we separately multiply. 13 3s are 39. Negative 39 upon 68 plus 13 ones are 13. 13 upon 34. So here LCM, in order to, now addition, in order to add we take the LCM of 68 and 34, that is 68 only. So therefore here we have to multiply 34, this second number, by 2 plus 13 upon 34 into 2 into 2. Why we are multiplying? Because we want to make the LCM, and to find the LCM, make the denominator equal by finding the LCM. LCM is 68. 34 and 68, LCM is 68. Therefore we, this 34, in order to convert into 68, we multiply by 2. Then we get negative 39 upon 68 plus 26 upon 68. Again addition, one is negative, another is positive. Then we subtract. When we subtract we get 13. Bigger number symbol is negative, therefore negative 13 upon 68. So here we have verified that LHS is equal to RHS. That is equal to negative 13 upon 68, and hence it is verified. Okay, here next this question A we have solved now, and question B, that is a homework for you. Using distributive property you solve and then you have to verify. Sixth question, find x if x is a rational number such that x into x is equal to x. Means one number, that is one rational number that is multiplied by itself, then the same number we got the result. According to the property we have studied that there is only one number, if it is multiplied by itself we give the same result, that is 1 only. Rational number is 1 or 0 is also a rational number. 0 into 0 is equal to 0. If a rational number is multiplied, if 0 is multiplied by 0 we get the answer 1 also. If we multiply 1 with 1, then we get 1 as the answer. So there is only these options. So the rational number can be either 0 or it is 1.